Welcome back to Podcast Name, where we dive deep into fascinating topics that shape our understanding of the world. I'm your host, and today we're exploring an ambitious project that merges philosophy with mathematics and computer science, a project that aims to formalize Bertrand Russell's groundbreaking work, Principia Mathematica, using the Lean theorem prover. Now, you might be wondering, what exactly does it mean to formalize a philosophical text? Essentially, it's about translating complex logical arguments into a format that a computer can understand and verify. This is not just about getting the right answer, but ensuring that every logical step aligns perfectly with the original text to avoid misinterpretations. To kick things off, let's talk a little about Russell himself. He wasn't just a philosopher. He was a pioneer in mathematical logic and analytic philosophy. His Principia Mathematica, co-authored with Alfred North Whitehead, is considered one of the foundational texts in modern symbolic logic and mathematics. It features some pretty intricate notation, known as piano-Russell notation, which is so sophisticated that it deserves its own entry in the Stanford Encyclopedia of Philosophy. That's how impactful it has been. Now, the project we're discussing is focused on the first volume of this monumental work, and the person behind this endeavor is clearly passionate about both the formalization process and respecting the original proofs that Russell laid out. What's interesting is that our developer attempts to maintain as much fidelity to Russell's original logic as possible while using Lean, a modern tool that's gaining popularity in the field of computer-assisted formal proofs. You know, it's fascinating to think about how mathematical notation evolves. I mean, have you ever tried deciphering complex mathematical expressions? It feels a bit like learning a new language, right? In this case, the formalization process is like creating a bridge between Russell's dense prose and a language that computers can navigate without getting lost. Speaking of languages, the project even includes creating specific tactics and syntax in Lean that reflect Russell's original notation, which sounds like a huge challenge. Imagine you're trying to teach a computer to follow poetic rules of logic while ensuring it doesn't miss a beat. That's pretty much the task at hand. The use of tactics like SIL enables the formalization of syllogisms, which, if you remember from high school logic, are a form of deductive reasoning. Now, I think it's worth mentioning some poignant reflections from the developer working on this project. They expressed that the Principia Mathematica is often regarded as a monumental failure by some scholars. That's a pretty bold statement considering its historical significance. They mentioned that, regardless of the criticism, engaging with Russell's work was an enriching experience, especially seeing how complicated theorems can stem from simpler initial arguments. This idea of building complexity from simplicity resonates across many fields, doesn't it? As we wrap up our discussion today, it's exhilarating to think about how formalizing mathematical texts can not only aid in greater precision and understanding, but also encourage new generations to engage with foundational works in mathematics. Do you think projects like this could influence future thinkers in philosophy and mathematics? Or, considering how complex the original work is, could it also create barriers instead of bridges? In summary, the effort to formalize Russell's Principia Mathematica in Lean 4 is not just an exercise in logic. It's a journey through intellectual history, reflecting the challenge of translating profound thoughts into a modern framework. It highlights the continuous dialogue between past ideas and present technology. Thank you for joining us today, and we hope you're as inspired as we are to explore the